Guys, just one more little review to help you with your test on Wednesday. If you can go through and say these statements, I can estimate the product of a multiplication problem using convenient numbers. I can estimate the quotient of a division problem using convenient numbers. I can recognize if I need to use multiplication or division to solve the problem. I can solve two-digit by one-digit multiplication problems using all partials, break apart, or open array strategies. I can write a related division equation from a multiplication equation. I can write a related multiplication equation from a division equation. I can model multiplication with base 10 pieces and arrays. I can model division with base 10 pieces and arrays. I can multiply using 10 or multiples of 10. I can use an array to find the missing factor in a division equation. And I can determine what to do with the remainder of a division problem based on the context of the problem. So let's take a look at the first one there. I can estimate the product of a multiplication problem using convenient numbers. Well, let's go ahead and delve into this. And let's take the problem 62 times 8 equals our product n. So we're trying to find n. Well, if I'm finding the estimate, we know that's an about. So if you would, pause this, see if you can solve this, and then listen to my solution. All right, let's take a look at the solution. First, we want to find convenient or nice numbers that are close to the number we're working with. Well, if I'm thinking of 62, I know multiples of 10 are easy to work with and multiply. So is 62 closer to 60 or closer to 70? Well, it's only 2 away from 60, so it's closer to 60. It's 8 away from 70. Anytime that we have a single digit, we should know our multiplication facts, so we should leave this as a single digit. So I'll still keep my single digit. So now I can solve this because this is multiplying with multiples of 10. So all I need to do is ignore the 0, multiply the digits that aren't 0. 6 times 8 is 48. How many zeros in my factors? Only 1. So I'll put 1 behind it. So the estimate for this problem, this multiplication problem, is 480. All right, let's go right on. Next, we're going to estimate the quotient of a division problem, and again, we're going to use nice numbers. So if I were taking 137 divided by 7, and we're looking for the quotient, so what would be some convenient numbers that we could use to estimate the quotient? Again, pause this, see if you can come up with an estimate using convenient numbers, and then start hit the play button again. All right, let's take a look. Well, we're dividing into groups of 7 or 7 equal groups. And 7's already an easy number because it's a single digit. So let's think about what kind of easy groupings that we can talk about times 7 that would get us close to the amount we have. So if I think in multiples of 10 again, 10 is always a good number to start with, especially looking at the numbers that we have here. So if I did 10 groups of 7, well, that would get me set to 70. So that's not quite enough. So then, remember, we're still using 7. So 7 groups, I'm going to go up to the next multiple of 10, because that's the next easiest number. And of course, that's 140. Well, 140 is close, very close to my actual number of 137. So a good estimate for 137 divided by 7 would be, how many groups of 7 did we make? So 20 would be my good estimate. because I can get about 27s from 137. Okay, let's keep right on moving. You can always pause or go back and listen to it again if you need to. This is a very important one. Can you recognize or identify when to use multiplication or division to solve the problem? It's very, very important. So let's take a problem that's related to our time of year. Let's say that Mr. Kid has 125 candy canes. He wants to share them equally with 5 students. How many candy canes would each student get? All right, just pause that, and then we'll reveal here in just a second what operation and why. All right. What is the information? We want to understand the problem. I have a total of 125 candy canes. I want to share them equally with 5 students. And what I'm looking for is how many candy canes would each student get? Well, I have my total amount of what I want to share. I know the number of groups I want to put them in, 5. So what is it that I'm missing? I'm missing how many ends up in each of those students' hands for those groups. So we know if we have the total and how many is in, or how many groups there are, then we know that this is a division because we know those two parts of the equation, but not how many is in each group. Or if you looked at sharing them equally, that is another clue to help you to figure out if it's division. Because if you're sharing them, dividing means to split up or share or separate. So we have the 125 candy canes, split them on 5 students, and that would equal the number of candy canes each student received. I'm not going to solve that. We'll talk about how to solve that division problem in just a minute. All right, so let's take another one just to make sure we're on the right track. Santa has 12 elves working tonight. Each elf can make 25 toys in one night. How many toys can the 12 elves make in one night. So again, pause it to see what you decide. Should you multiply or divide, and why? All right. So let's take a look at the information that's given to us. We know that there are 12 L's working. Each elf can make 25 toys in one night. So we have the information. We know the number of elves. We know how many toys each of the elves can make. So I know my groups. I know how many's in the groups. So let's look at our question. How many toys can the 12 elves make in one night? So that's putting all 12 elves together, what they made. So we know we're missing the total. So we know if we have groups of the same amount, so for every 12 elves, they made 25 toys each, would give us the total amount of toys that they can make in one night. Because we have 12 groups, 25. So one elf makes 25, two elves, so that's 25 plus 25. Three elves will be 25, 25, 25. Okay, so you can always draw that out. So we know the groups, we know the number that each group made, and so therefore we can find the total. So this is a multiplication problem. Remember, one of the keys in determining if it's multiplying or dividing, it's not looking at keywords in the problem. It is thinking about what is happening in the problem. If it is multiplication, is joining the same amounts. Division is separating in equals groups or amounts. Very important is to visually see. So try to see what's going on in the problem. Okay. All right. Next one. Solve a 2-digit by 1-digit multiplication problem using all partials, break apart, or open array strategies. So let's delve right into this. Let's say we had 72 times 6 equals n. So you should be able to solve this and be able to determine all partials, break apart, or open array strategies. So let's use all partials first. All partials is basically separating our numbers into its place value. So if we look at 72 times 6, first we see that we can separate 72 into 70 plus 2. So therefore, instead of just trying to do all 6 times 72 at one time, we can do 6 times 2, which is 12. And then we have 6 groups of 70, not 7. That's 6 groups of 70 because the 7 is in the tens place. So then we have 6 groups of 70. 6 times 7 is 42 and 1 0. So make sure we write the numbers down correctly. So I have multiplied all my groups there in each part of my group. And then these are my partial products here and here. So I add these to get my total. 2 plus 0, 2. 2 plus 1, 3. And then 4. So 400 32. That's using the all partials. Well, we should also get the same thing if we use the break apart. So if we wanted to, we could break a problem into two easier parts, not necessarily by place value. So let's say we had 24 times 7 equals n. So I can look at 24 as 12 plus 12 also. I don't have to separate it by its place value. So then I would have to make sure that I multiply 12 groups of 7 and then another 12 groups of 7 and add them together. So 12 groups of 7 plus another 12 groups of 7 equals our n. So this is a multiplication fact. So 7 times 12, 84, plus another 84 is equal to 168. So this is another way we can break numbers into 2, 3, 4 numbers, whatever it takes to make the multiplication easier, as long as I count for all the groups and everything that's in each group. And of course, the open array model, okay, is we can take we'll take that same problem that we just did, okay, 24 times 7, so we've got 7 rows of 24. So we can 1, 2, 3, 4, 5, 6, 7, 7 along this side, and then this will be 10, 20, and then 1, 2, 3, 4. So then we can break the array apart, this open array, into whatever we would like to. So we could break it here. So this array would be a 7 by 10. We could break it here also, so that would be another 7 by 10. And of course this would be a 7 by 4. Okay, so the number of squares that would be here, 70, 70, and 28. And then if we add all these up, because this makes up the bigger array, 70 plus 70 plus 70. Oh, excuse me, I made a mistake there, didn't I? I got carried away with the 70s. Plus 28. 14 and 2 is 16. As you see, we got the very same thing. Okay, so just a different way of looking at and modeling this multiplication. All right, let's continue right on. Let's take a look at the next one. Write a related division equation from a multiplication equation. All right, so let's take a look at that. What does that mean? It sounds fancy, but we know that division and multiplication are related. So let's take a multiplication equation, any one whatsoever. If I say 42 times 4 is equal to, of course I'm going to do all partials here, so 4 times 2 is 8. 4 times 40 is 160. Wow, we got another 168. How about that? So this is 168. So what we're doing is we're taking this and writing this using the same exact numbers, 168, 4, and 42, and writing a related division equation. So remember, division is the opposite. So we take that total amount, 168, and if we divide it by 4, we will get 42. Likewise, that's not the only one. We could say 168 divided by 42 would be 4. So that relationship is very important, those related division problems to the multiplication. Remember in class we talked about if you know 1, you can get 3 for free. Okay. So let's see, we're going to go right on to the next one. Write a related multiplication equation from a division equation. So this time after I write this, you try this one, pause it, and see if you can write the related multiplication equation from the division. So if I said 72 divided by 9 is equal to 8, what would be the multiplication equation that we could write that's related to that? Okay, hopefully you paused it. So, fairly simple, we're working backwards. So if 72 divided into 9 equal groups equals 8 in each group, then if I take 8 groups, put 9 in each group, I'm going to get a total of 72. Or you could have also written 9 groups of 8 was also equal to 72. Okay, fairly simple. Let's continue on. Model multiplication with base 10 pieces in arrays. So if I'm on the multiplication, so let's do something simple here. If I was doing 12 times 6 equals a number. So with base 10 pieces, I have 12 groups of 6 or 6 groups of 12. I want to do the larger. Okay. So if I'm going to do 6 groups of 12, 12 in each group. Okay, so how would I model 12? Of course, we all know that. That's a skinny and 2 1. So that's 1 group of 12, 2 groups of 12, 3 groups of 12, 4 groups of 12, 5 groups of 12, 6 groups of 12. So I've just modeled 6 groups of 12. Fairly straightforward. Same thing with division. So let's say we had 64 divided by 4 equals a number. So again, I want to use my base 10, so I'm starting with 64. So I can write 64 as 1, 10, 20, 30, 40, 50, 60, 1, 2, 3, 4. And I'm going to try to put that into 4 equal groups. Right? So I could, how many could I put right from the start? Well, I can put a 10 in each one. So if I put a 10, 10, a 10, a 10, I've used a 1, 2, 3, 4 tens, because 4 times 10 is 40. I now have 24 left. Well, I can't put a whole in each, but if I split that 10 in half, so 5, 5, 5, 5, okay, so I could put 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay. So that uses this skinny and that skinny, and we're still all split equally. I have 4 ones left, and that's simple. If I put 1 more in each, I've used all 64. So 64 divided into 4 equal groups, I can count now how many I have, is 10, 11, 12, 13, 14, 15, 16. So 16, so n would equal 16. Real quickly, with multiplying using 10 and multiples of 10, just a quick refresher. When we multiply using 10, the pattern is that the number that we multiply by 10, in this case 3, we write that digit and then put a 0 behind it. That goes for any number we multiply by the number 10. So if I had 10 times 27, 27, put a 0 behind it. If I did 10 times 246, try that one, pause it, think about it. I would write the number I'm multiplying by 10, put a 0, so that would be 2,460. Now, this helps us because then when we start to multiply with multiples of 10, such as if I did 30 times 6, I ignore the 0, multiply the digits that aren't 0. So in this case, 3 times 6 is 18, and count the number of zeros in all my factors. In this case, I only have 1 0 and none next to the 6, so I would put 1 0. So 6 times 30 is 180. So try this one. If I had 8 times 90, pause it and see if you can do that. Maybe you want to try it in your head. So hopefully you multiplied 8 times 9, 72. There's 1 0 in my factors, so 720. This is very important. You must know how to do this so that you can do all the forgiving method in division and all your strategies for multiplying. Moving on, you should be able to use an array to find the missing factor. So if I give you the total for what's in the array, so if I said there were 84 in the array, and this side was 7, what would be the factor that would go with it? Okay. So we could either write this as 84 divided by 7 equals our missing factor, or we could say 7 times our missing factor will give us 84. Either way. And F would be 12 in this case. One of the strategies, if you didn't know that already, and you had me working with a larger, let's take that same one. So this is 7. You know that 84 has to be the total here. You know that 84 is the total amount in here. So first of all, if I did 10 in each of those 7 rows, I would have 70. That would leave 14 because 84 minus 70 is 14. So now I'm thinking 7 times what? So I know this has to be 14. So 7 times what gives me 14? 2. So therefore, you can see we still came up with 12. So we can break that down to help us figure that out. Determine what to do with the remainder of a division problem. Very important, because you must know what's going on in the problem. Different cases call for different answers. So let's say that the 4th grade is going on a trip to the museum. There are 21 students in Mr. Kidd's and Mrs. Spellman's classes. Each band can hold 8 students. How many bands will it take for all the students go. If you would, pause this, read it a couple times, try to figure this out, and I'll give you the solution in just a second. All right, let's take a look at this. Take a look at the information. What is all that? That understanding the problem is crucial. So we're going on a field trip. We've done that before, so that's familiar. So we need to know, hopefully, how many's going. It says there are 21 students in Mr. Kidd's and Mrs. Spellman's class. Okay, so that's important. Each van, okay, that they're taking can hold 8 students. Okay, so we can't go fit everybody on that in one van because it only holds 8 students. So we also must know, well, what are we looking for? Well, we're looking for the number of vans it's going to take so that all the students, and that's important, all the students can go. All right, so let's see what you did first. In order to find out how many students, if we know that there are, in Mr. Kidd's class, there are 21 students, and in Ms. Spellman's class, there are 21 students. To get our total amount of students, we would just need to add those two together to get our total number of students, because that's important. We don't know the total number of students, we won't know how many vans. So this is the total number of students. So now, we are separating these 42 students into vans that hold 8 students. So every time we get 8, we get a van. So we're trying to see how many groups of 8 we can get from 42. Well, if we use the forgetting method, I'm going to take my 42 students, putting them in groups of 8. So I'm trying to find the closest one, use up as many of these students as I can. So I know my multiplication factor. So if I do 5 vans, with 8 students in each van, that will take 40 students to the museum. Now, I've subtracted this out because now I've got those 40 students. That leaves me 2 students still left to go. So the answer to the division problem is 5 remainder 2. And again, just a reminder, this must be less than this for you to stop dividing. Okay? Because we need at least 8 to fill up a van. So now the question was, how many vans will it take for all the students? The answer is not 5 remainder 2. We have to look at the context. We want all the students to go. And if you notice, there are 2 more students that we haven't put on a van. We put 40 students on a van, but there are 2 students that haven't gone. So we're going to need 1 more van here, along with our 5 vans here, okay? So 5 vans plus 1 more van. So the answer to the question is 6 vans. Again, must read very carefully what the problem is asking you. So make sure that you go back and do step 5. We've done our action plan, we've carried it out. So is our answer reasonable? Does it make sense that about 6 vans? Well, yeah, it does, because I know that 5 times 8 is 40, so 5 vans would take almost all of them. So that's reasonable. Now, did I answer the question? That's important. So for all the students, so I would have 5 vans taking 40 students, and then 1 more van, even though it's not full, would still have to take those 2. So yes, my answer, I did answer the question. It takes 6 vans to take everybody. Well, I hope this will be beneficial. Uh, if you have any questions, jot them down, and I will answer them in class. Have a great evening.